Good morning students. Few numericals we are going to discuss today again. Now the first numerical which we are going to discuss is this one. What is written here? You see, a bullet fired at an angle of 30 degree with the horizontal hits the ground 3 km away. By adjusting its angle of projection, can one hope to hit a target 5 km away? Assume the muzzle speed to be fixed and neglect air resistance. So this problem is the topic which we have discussed related with the projectile. So what are the given parts given? Let me write it first of all. So given theta equal to 30 degree, r, that is your horizontal range, is your 3 km, it means 3000 meter, and g equal to 10 meter per second square you can consider. Some of you can consider 9.8 also, that is also correct. Now the formula which you are going to define is your r equal to u square sine 2 theta by g. So already we have discussed this expression. So let me substitute the value. Implies r is given 3000 meters, so 3000 equal to u square by g, and sine is your theta is your 30 degrees, so sine 60 degree. So 3000 we can write 3 into 10 to the power 3 u square by g, and sine 60 degree is your root 3 by 2. So u square by g, let me take it out here one side. So it becomes your 3 into 10 to the power 3 into 2 by root 3. So if you simplify, it becomes your 2 root 3 into 10 to the power 3 u square by g. This is your number 1. Now the maximum value of r is your what? Maximum value of r is your u square by g under the condition when sine 2 theta is equal to 1. So r max we have written u square by g. So from 1 and 2, this is number 2. So from 1 and 2 you can write r max equal to 2 root 3 into 10 to the power 3 meter, or 2 root 3 kilometer. So the maximum horizontal range with this parameter is your 2 root 3 kilometer. But since the target is 5 kilometer away, so definitely it is not possible to hit the target, because it says that by adjusting its angle of projection, can one hope to hit a target 5 kilometer away. So whatever range depends on the parameter u square sine 2 theta by g. So these are the parameters. So the maximum value for r max is your u square by g. So under any circumstances, it's not possible to go beyond the value of r max, which is your 2 root 3 kilometer, and the target is 5 kilometer. That's why it is not possible. So please check out this one. Now the next sum which you are going to discuss is this one. It says that an aircraft executes a horizontal loop of radius 1 km with a steady speed of 900 km per hour. Compare its centripetal acceleration with the acceleration due to gravity. So let me write the parameter. R equal to 1 km means 10 to the power 3 meter, and v is your 900 km per hour. So 900 into 10 to the power 3, and 1 hour is your 3600. So it's your meter per second. So if we simplify, you will get 250 meter per second. And the expression for the acceleration is your already have defined a equal to v square by r. So substitute the value. 250 into 250 by radius is your 10 to the power 3. So if you simplify, 625 into 10 to the power 2 into 10 to the power minus 3. So it's your 62.5 meter per second square. This is your centripetal acceleration. Now it is asked to define the ratio centripetal acceleration to the acceleration due to gravity. So here we are considering acceleration due to gravity is your 10 meter per second square. So if you take the ratio 62.5 by 10, you will get 6.25. This is your second sum. Now the next one which you are going to discuss is this one. This is your diagram. As per the statement, a cyclist starts from center O of a circular park of radius 1 km, reaches the edge P, then cycles along the circumference and returns to the center along QO. So it starts journey from O and again comes back to O. If round trip takes 10 minutes, what is the net displacement? Number 1, number A. Number B is your average velocity. Number 3 is your average speed. Now you see net displacement is 0 because from where it starts, it comes back to that point again. So net displacement is 0. Now the average velocity expression is your net displacement by total time, total displacement by total time. So as here net displacement is 0, that's why average velocity is also 0. Now what left? The third one, that is number C, average speed. So average speed formula is your total distance by total time. As it starts from O and reaches to P, so OP plus whole circumference you can consider, or you can say OP and moves to the circumference again, not whole circumference, only the part of the circumference. O to P, then P to Q, then Q to O. That is your OP plus PQ plus QO divided by total time. So OP is your 1 kilometer as specified in the question radius, and PQ is your you can consider arc equal to angle into radius. So angle is your 90 degree. So as per the diagram, pi by 2 into radius. Use the formula arc equal to angle into radius. And next again along QO, that is your radius again. So r plus pi by 2 r plus r. So here we have considered arc equal to angle into radius, and arc is your PQ. So angle is your pi by 2 into radius. Now radius is your 1 kilometer given. So 1 plus pi by 2 plus 1. And time is your given 10 minutes. So make it in hour, 10 by 60. 10 by 60 is your hour. So 1 by 6. So if you simplify by substituting the value of pi is your 3.14, you will get 21.426 km per hour. So please check out the calculation part by yourself. So I think you have understood. The journey starts from O, reaches to P, then moves to the circumference PQ and moves to O by covering QO. So net displacement is 0, net velocity is also 0, average velocity is also 0. So only the average speed remains. So that is your 21.426 km per hour. So please go to the numerical from the exercise as well as from the example part. This part is very important for your exam point of view. Let's see whether we can continue with the numericals in next class. Then we'll go for the next chapter. So please put your doubt if you have any. We'll try to sort it out. Thank you.